Algebra 2 Cram, New York State, Algebra 2 Regents, Common Core, Basics, Sign of Trigonometric Functions, Concept number 12, Quadrant 1, and Trigonometric Functions. Now, the odds of someone doing exactly what you tell them to do is pretty slim to none, but I guarantee that if you cram with me, you'll become an Algebra 2 master. What we're doing here is super effective. I'm coaching you to turn your wants and desires of getting an A or perfect test scores into a brand new paradigm. I want to include everyone who needs a boost in Algebra 2. And trust me, if I could take a syringe filled with a healthy dose of eye-opening awareness of mathematical genius, I would probably stick you and every other Algebra 2 student with it. For good intentions, of course. So inbox me with memedicine@gmail.com to get your healthy dose. You have lots of peers, classmates, colleagues, and our friends who are taking Algebra 2 with you who could also use a healthy boost. So tell them to inbox me at memedicine@gmail.com so that they too can order this entire Algebra 2 cram session. And last but not least, cramming often gets a bad rap. But what people are actually thinking of is hurrying, which is a result of fear and can consequently be destructive. We're not hurrying, we're cramming. There's a difference. Hurrying is taking tons and tons of unorganized information and loading it onto your mental, spiritual DNA over a very tiny amount of elapsed time, whereas cramming is taking quantum leaps in your understanding in an organized way in what seems like an instant. So let's delve into the concept 12 topic of Quadrant 1 and trigonometric functions. Quadrant 1 and trigonometric signs. Express the trigonometric functions of an angle theta, and when I say trigonometric functions, I mean the three basic trig functions and their cofunctions such as sine, cosecant, cosine, secant, and tangent, cotangent, okay? So of an angle theta in quadrant 1 as a function of its reference angle 𝜃𝑟𝑒𝑓. So I'll definitely give you a moment to think and definitely press pause if you need to, okay? So just to give you more clarity, here goes our angle theta in quadrant 1, and we want to express all its trig functions as a function of its reference angle theta sub ref, which is short for reference angle. Take a moment to think and definitely press pause if you need to. All right, so hopefully by now you were able to press pause and come to your conclusion and draw out your answer or write out your answer. And if not, that's completely fine. That's why we're here, to solve this step by step in an organized way together. All right, so the first thing that you need to establish in your mind so that everything can flow nicely in an organized fashion is that the signs of trigonometric values, and when I say signs, I mean either the positive sign or negative sign, depend on the signs of the x and y coordinate or values of the quadrant in which the terminal side of the reference angle is found. Okay, so it all depends on the terminal side of the reference angle, where it lands in this wheel of fortune, or you could call it, okay, it's Cartesian coordinate plane, okay? And before expressing the trigonometric functions in quadrant 1, we need to understand the concept of standard position. Doing this simplifies finding all the trigonometric values. So an angle theta, which is what we're looking at here, in standard position in quadrant 1 has 6 key features. The first key feature is that its vertex is located at the origin that has the xy coordinate 0, 0 respectively. The ray shown here So this ray on the positive x-axis is the initial side ray of this angle theta in standard position, also located in quadrant 1. And the other ray terminates in quadrant 1. It's called the terminal side ray. And we'll be cute and call this ray R for short, okay? And let's say we arbitrarily choose a point that we're going to call P, obviously short for point, and we plant it right here on our terminal side ray, okay? It's going to have the imaginary coordinates x and y. I bet you figured that one out really quickly. All right. And so for our purposes, we're going to say that this terminal side, which was formerly a ray, but is now a line segment, extends to the extent of its x-coordinate, which is x, and rises to the level of its y-coordinate, which is y. But looky, what do we have here? We have the resolution of this segment, which now looks like it's going to be a right triangle. So we'll just make pretend and, denote that we have a right triangular formation like so, okay? All right, so hopefully you're good to go. And notice, although the x and y coordinates are going to, well, x is going to be positive in quadrants 1 and 4, and negative in quadrants 2 and 3, obviously it's going to be positive in this particular session because we're dealing with quadrant 1. And notice that y can be positive in quadrants 1 and 2. For our purposes, it's positive here, but negative in quadrants 3 and 4. So the x and y coordinates take on signs. And this is what's going to give us the signage on our various trigonometric values. Okay, but notice I said that the x and y coordinates in quadrant 1 are all positive. So that should give you a big hint on the actual signs of all our trig functions that we're going to build a foundation for here today, okay? But then we have our guy Ray. Is he positive, negative, sometimes negative? Well, a ray is a segment, okay? So the measurement of a segment is going to be its length, and lengths are always going to be positive, okay? So our ray has a measurement of the square root of its x-coordinate squared plus its y-coordinate squared. And you might notice this is a play on the distance formula, x minus x squared plus y minus y squared. But the convenient thing about standard position is that one of the coordinates that I previously mentioned is 0, 0. The x-coordinate being 0 and the second position y being 0 as well. So 0 is implicit. Here you don't necessarily need to write it. And squaring the x's and squaring the y's and then taking the square root of the sum of both is going to just undo any negatives. So r or ray or the hypotenuse is always going to be positive, okay? Thus, something that I'm just going to tell you because this is what has been established in Algebra 2 in trigonometry, is that the reference angle for such an angle in standard position in quadrant 1 is basically just going to be itself. So theta is its own reference angle, okay? I just wanted you to understand that. So theta equals 𝜃𝑟𝑒𝑓, and I just neatened things up a bit and took away all that mess. Here goes our guy array, the x extent, the y extent. And so for any angle in quadrant 1, it's its own reference angle. And why is this reference angle mumbo jumbo important? Well, because when you calculate trig functions in your calculator, more specifically inverse trig functions, they're calculating based on the reference angle. But and reference angles are always acute between 0 and 90 degrees. So usually the calculation is done for any angle between 0 and 90 degrees. But you can do a horizontal flip, and this terminal side ray could end up in quadrant 4. You no longer have an acute angle, you have an obtuse angle, but your calculator may still give you the value for this guy when in fact you may be interested in something looking like this. All right, but don't worry. Stick around for the next few sessions and purchase the entire Cram session, and you'll get to find out what the trig functions are for other angles that don't terminate in quadrant 1, where the reference angles are not equivalent to the angle itself, okay? All right. Okay, so let's get on with this. For any angle in quadrant 1, all the functions are going to be positive. That is, all the trig functions are going to be positive. And why again? Because the x and y coordinates are positive, and the measurement of our hypotenuse segment length is always going to be positive. But to better elucidate why this is, let's roll down all the trig functions, okay? So first we have the sine of theta. Well, we know that the sine of any angle theta, here we're really dealing with the reference angle, is equivalent to the side opposite theta, which corresponds to the y-coordinate, divided by the hypotenuse, which corresponds to the segment length. So the sine of theta, we want to know as a function of its reference angle, is going to be equivalent to the y-coordinate divided by r, or the segment length. And let's also wrap up the value of the co-function, which is the cosecant, or the reciprocal of the sine function, and that's just going to be r over y. Notice that in all the co-functions, the numerator is always going to be the hypotenuse, okay? Let's move on to the cosine of theta, and that's going to be equivalent to the cosine of 𝜃𝑟𝑒𝑓, because our 𝜃𝑟𝑒𝑓 is equal to theta. We don't need to change anything. And that's basically going to be equal to the side adjacent the angle, which on a Cartesian coordinate plane corresponds to the x-coordinate divided by the hypotenuse, which is the segment length. All positive, all good, and let's go ahead and sum up its co-function, which is secant, which is just basically the reciprocal of cosine. So it's going to be obviously the hypotenuse divided by the adjacent side corresponding to the x-coordinate, okay? And last but not least, we have tangent, which never involves our hypotenuse, just basically the value of the opposite side divided by the adjacent side. Here, our tangent of theta is equal to our tangent of 𝜃𝑟𝑒𝑓, because 𝜃𝑟𝑒𝑓 equals theta. And that's obviously going to be equivalent to the opposite side, as I previously mentioned, divided by the adjacent side. The opposite side corresponding to the positive y-coordinate, the adjacent side corresponding to the positive x-coordinate. And let's sum up the co-function, which is just the reciprocal, or the adjacent side corresponding to the x-coordinate, divided by the opposite side, which corresponds to the y-coordinate. Hopefully I didn't chat you up too much, but as you can see, grasping this material is not difficult at all. And in the short amount of time it takes you to review this entire Cram series, you'll be able to answer a battery of questions about everything Algebra 2. So inbox me at memedicine@gmail.com to order this complete Cram session. Thanks for tuning in.